So everybody, welcome to the Memory Labs, CockroachDB or Cockroach Labs, webinar today, where we're going to cover architecting persistent long-term memory for multi-agent systems. Right? My name is David Joy. I'm a senior manager, sales engineer here at Cockroach Labs, and with me today I have Adam, who's the CEO, co-founder of Memory Labs, a partner who we have been working very closely with. Adam, why don't you introduce yourself and a little bit about what the company does?
Yeah, for sure. Hey, everyone, pleasure to meet you. As David said, I'm the co-founder and CEO of Memory Labs. We basically see ourselves as foundational or seminal agentic infrastructure, and the goal is to give your agents persistent contextual awareness in an LLM agnostic manner at the API layer. So, a very critical problem to solve in today's agentic workflows.
Perfect. Thank you so much, Adam. So today we have a really great, webinar for you. This is one of our first partner webinars that we're doing this quarter. Today, as an agenda, we're going to cover some really interesting things for all of you. Obviously, this particular webinar is focused around memory and building persistent memory at scale and with, resilience. So we're going to cover all of those things. So as an agenda, like we're going to cover at least 7 of these things that you see here. We're going to talk about the agentic world challenges. We're going to go in and talk about, what memory really does and why Cockroach is the right database for you to build when you're building persistent memory with at scale and with resilience. We're going to cover a little bit by looking into the architecture and how our integrations work. And then from there, we'll show you a demo. We'll talk about the use cases and how it can help your business and then how you can get started. So we're going to cover all of those things. We're going to have a really good interaction. So feel free to like jump in and ask questions wherever you find you want to learn a little bit more. So if you can go to the next slide, let's start with the agentic world challenges. Right now, this is not new. I'm sure all of you, wherever you are right now, are hearing about agents, AI. And this is like it's not a new thing anymore. It's sort of becoming a reality in today's time. So we know that AI agents are going to become relevant and going forward, they're going to become much more important, right? But we did a little bit of analysis trying to go and understand where this is going. And we are coming to realize that the AI agent explosion is pushing the limits of scale. About 80% enterprise adoption has only happened per 2024 data, but we expect these agents to basically we expect it to go to 1.3 billion AI agents. And imagine a world where each one of us has 5, 6, 7, maybe 20 agents doing our things. So the question there is that it's no longer the question, can we deploy agents? I think in 2026, we know that we can deploy agents, we can get them to work. But the question is whether you have the infrastructure to actually keep up with this level of AI agent explosion. And that's what we are going to address in today's conversation with Adam. Adam, if you can go to the next slide. The second piece we have to consider is while you might be able to bring together AI agents, right? You will be able to scale AI agents. The second question is, can your infrastructure keep up? Today, 98% have confirmed that there is a high downtime associated with downtime associated with AI. So if an AI agent goes down or if your infrastructure goes down, you're losing tens of thousands of dollars per hour sometimes, right? Or per minute sometimes. And this is extremely complicated. This can complicate the overall user experience and a lot of other things that come with it. And at Cockroach Labs, we did a research study where we looked at the state of AI infrastructure in 2026 to really understand, is the world that we are building for, will it be scalable? Will it be resilient? And from what we are seeing right now, data suggests that there is a high prediction that the demand that we see is going to cause really high infrastructure failures. So as you're building today, you have to start making these considerations in your infrastructure layer. All right, and a third one that I will also introduce as a challenge that we see, if we go to the next slide here, is AI agents lack persistent memory across context flows. Now, this is something I'm sure a lot of you who are playing around or building these systems are already experiencing. When you use an agent, when you have multiple context flows where you have different models, different sessions, different multi-agent workflows going on, there's a big struggle on how can we make sure that an AI agent remembers what we did and discussed in one workflow. How can we make sure that this is persistent so that the agents actually have some sort of a memory? So this is really associated with what can we do to make sure that there's persistent memory across all of these different context flows. And one of the things that we are realizing is that These agents, when they don't have the right amount of memory and not the right amount of information, they are starting to make the same mistakes. And that is associated with using tokens. And more tokens you use to solve the same problem you might have solved yesterday is going to incur cost, and that cost is going to affect how the business runs. So these are real problems that we are seeing, that folks will have to start addressing. And that's why we have taken up this opportunity to bring Adam here so that we can do and talk to him and talk to you guys about how we can help you solve these problems as you build persistent memory, as you build AI agent systems, especially multi-agent systems. So, Adam, I'm going to pass on to you because this is your world. You live in this world. You're talking about solving these problems. So, help everyone kind of understand what is the issue with memory and how we can solve that.
Thanks, David. Appreciate it. Yeah, so I thought, first we should start about sort of today's memory stack and why it fails. Some people think that memory is the same as rag in a box. From our perspective, it's really not the same. If you chunk a document and vectorize it and try to recall it, that's not the same as sort of a memory pipeline that can actually structure memory primitives, not just from long conversation, but also agent tracer execution. And that can also sort of put these memories on different decay curves. So you have this always evolving, continuously evolving memory knowledge graph. So just wanted to say that we think we're way different than just a sort of generic RAG pipeline. Another big thing is when my co-founder Mike and I decided to build memory, we wanted to do it in such a way that the largest enterprises, many of which are Cockroach customers, would actually use our product and make it easy as possible for them. So some of the other memory players out there force you to create like custom hybrid stacks. You have to use sort of graph Falcor databases, things that don't scale, things that are not supported by AWS. Our whole goal was to sort of build a sort of memory solution that doesn't force new infrastructure and sort of turn this whole exercise into an infrastructure science project. Another thing that's really critical is you might be saying, hey, I see when I use Claude or GPT, there is memory. But from our perspective, it's very, very critical that that memory is LLM agnostic. You want your memory or your context layer available to you at the API level that you can pick up and take with you wherever you go to prevent vendor lock-in. We believe that the current and future is multi-model. And then lastly, which I kind of hinted at, memory solutions that only focus on long conversation natural language and sort of extracting memory primitives from natural language, we think misses a lot of the key opportunity here. If you want your agents to continuously get better and actually learn from their mistakes, you have to go through the very difficult task of structuring memory primitives from agent trace, which is much harder than natural language. So we also think there's a deficiency in existing systems because they don't focus on agent execution. So let's meet memory. So memory is structured memory from agent execution powered by CockroachDB for agentic scale and resilience. So yeah, just double clicking on this, we're the only memory layer built for agent execution. So every tool call, constraint, and decision your agent makes is context. Other systems only see the conversation. The difficult thing is if you actually analyze the agent trace, so the tools, the commands, everything that happens under the hood, it doesn't look like natural language. So the ability for, at the memory creation or what we call advanced augmentation level, to actually understand what should be durable, what is considered agent exhaust and should be forgotten, those are very difficult things to do, to then sort of normalize it, structure it, and put your agent in a place that they can retrieve the right memory at the right time. That's a big part of where we see our differentiation. As I mentioned here, in our opinion, intelligent memory has to be LLM agnostic. So memory intercepts queries across any model, learning from every interaction to reduce redundancy and deliver personalized, consistent product experiences. We think AI right now is really early. Enterprises are really just starting to use, some of the foundation models, but we really believe the future is, people using open source models, people using local, maybe CPU bound models. You want to be in a situation that all of your persistent contextual awareness is, that you can take it wherever you want, take it wherever you go. So this is a big thing to point out as well. The Snap Research Lab created something called LoCoMo, which is basically a way to benchmark your memory solution. And the nice thing about memory is we literally scored the highest on accuracy at the lowest cost. I'll show you a demo later on in the presentation, where we actually go through a long conversation demo, but we are literally seeing 95% reduction in token spend or inference spend using memory versus injecting full context into the prompt. So the efficiencies are exceptional. And then, I think what's also really important is that we are a SQL native layer. We do not want to force you to use, sort of graph databases. Memory is stored as structured entities, relationships, and sessions in standard SQL databases, and this makes it queryable, auditable, deterministic, and compatible with the enterprise infrastructure teams already use. And that's also why we so appreciate working with Cockroach Database, given they're an RDB. I'll hand it over to David. David, maybe you can tell us a little bit about Cockroach Database so the audience can understand just how important it is to have a database substrate that can handle agentic scale and resilience in this scenario.
Yeah, awesome. Thank you, Adam. So, before this webinar, we were connecting and we wanted to help you understand, obviously, the memory piece, but also why having an infrastructure for memory also needs a scalable database, right? So, CockroachDB, I mean, if you're not familiar, is basically a distributed SQL database, and it's basically built to solve the problems of resilience and scale. And that can be applied across multiple different use cases. But as we communicate and as we work with a lot of our enterprise customers who are also building for agent and looking for agentic memory stuff, we found a really good companionship and partnership here with Memory, who are already building this infrastructure and they needed a database. So that's where Cockroach actually is the database that powers and supports where the actual memory information is stored. But what makes Cockroach really unique is that Cockroach essentially is a the way you want to think about it is it basically is an asset compliant, or a relational SQL database that can scale, across multiple regions and can always be on. And the benefit of that is as your agents start to build, you actually get support of a database that is always resilient, always on. So one of the beauties of CockroachDB really is that you can actually run it as a distributed system that runs across multiple regions, multiple instances, and you have the benefit of scale. So as your agents scale from, say, you are at 10,000 agents and suddenly you go to 100,000 agents to support that infrastructure of database, Cockroach will, you just have to keep adding, more Cockroach nodes and it will continuously evolve. And what we also provide to the industry today is a native vector search capability in our database. And we also support, agentic ready platform capabilities like MCP server, agent skills, and we also release the CLI to help you build all of these things. But the most important, most crucial thing I want you to know is the experience of using Cockroach is the same as a relational database. What we provide is transactional guarantees because we are like a relational database, but we can scale and are always on. So just to help you understand, let me help you understand how we visually kind of can help you understand here. So build once and scale agents forever. That's what Cockroach kind of brings. So if you are at, say, 7 agents hitting a 3-node Cockroach cluster, it works together as a single logical cluster. But now, if you go to the next slide, as your agent execution increases, as more and more agents keep coming, all you have to do is basically keep scaling the database without limits, right? So as agents scale, keep adding more nodes and you will have no problem. And the other benefit is that even if a node actually goes down, because we run together as a distributed database, data is actually copied across multiple instances. So even if a node goes down, if a couple of nodes go down, agents will have no problems because for them, the experience they're getting is that basically the system is always on. So what we guarantee is agent business continuity. So for all of you who are going to build on memory with CockroachDB, you will build once and you'll run agents forever. And that's the experience we are trying to build. And when we started working with Adam's team, we realized like this is where we wanted all of you to understand that the challenges of scale and resilience are very important when you build this new multi-agent systems. So I'll pass on to Adam. Adam, you covered some interesting points. Let's go a little bit more into it and kind of learn more about memory with Cockroach.
Yeah, thank you. Yeah, so I think what's great about sort of our relationship and the integration that we have is you can literally provision and orchestrate a dedicated Cockroach cluster natively with one click. We support essentially cloud-based deployment methods, bring your own database, and for enterprise customers on-prem as well as VPC. And then if you're using Cockroach database, you can ensure then that you have complete data sovereignty, regional compliance, and distributed deployment. Here's just a quick sort of reference architecture so you can understand that sort of where we sit in relation to your application and the storage layer. And then, yeah, why don't we dive in a little bit more into what we call advanced augmentation. So advanced augmentation is essentially the memory creation process. So memory captures every query before it hits the model. So we actually sit in between the enterprise and the LLM. We automatically send every conversation and agent trace to advanced augmentation. And then with advanced augmentation, we normalize instruction memory primitives from the agent's most important interactions. So the way that we deal with sort of what we would call natural language long conversation is we're going to take, facts, skills, rules, preferences, events. We're going to reduce them to semantic triples. We're going to vectorize them. We're going to put them in time and space. And then we have a very sort of proprietary way that we choose to retrieve those memories at the right time. And then if you're using a harness or it's more of the agent native version of memory, it's not sort of in long conversation context. It's more just the agent completing complex tasks on your behalf. In that scenario, we will actually take the agent trace that's created as a byproduct of the agent execution, normalize it, create structured memory primitives, and then in that scenario, we can give the agent the ability to recall sort of memories in more of a deterministic fashion. And then we also have various forms of automated retrieval as well. So yeah, why don't we now talk about sort of intelligent recall? So I mentioned this earlier. This is where we believe we're very differentiated because not all memories are equal, right? My daughter's name is Scarlett. That's a memory I never want to forget. I had water yesterday, maybe not so important. So the critical component for us is when we create memories, we actually put them on different decay curves, depending on type, preference, facts. There's probably 15 different variables that go into where a memory is going to be on its decay curve. We have various forms of automatic and intent-based injection, so relevant memories are injected into every LLM call. If it's an agent-native version, they have the ability to perform explicit retrieval. And then as mentioned, right, because each memory is on a different decay curve, they're going to be ranked differently. That sort of creates that always-on, always-evolving knowledge graph. The knowledge graph will evolve and strengthen, building richer connections over time, literally based on how the user or the agent is recalling the memories. I now have two demos for you that are going to show how memory works. Purposely wanted to cover both scenarios. So sort of the long conversation demo, where you can see how memory retrieves memories and creates session summaries to give you the most accurate response during a live conversation at a fraction of the cost. And then we'll move to the agent trace and execution demo. All right, so let's pull this up. So this has really been taken from the LoCoMo benchmarks. See how memory works is it retrieves memories and creates session summaries to give you the most accurate response at a fraction of the cost. There's a bunch of conversations here. I'm going to select conversation 43. So what you can see here is this total conversation between John and Tim. It's 24,229 tokens. If I scroll down, it's going to take a while to get through the whole conversation. So there's a lot there. So the first thing that we're going to do is we're going to generate memories based off of the full context conversation. So memory right now is essentially taking all of the important facts, creating semantic triples. For the purposes of this demo, we've just shown you a sort of more rudimentary form of what the memories look like, but you can see here, like the first memory that it generated is John signed with the Minnesota Timberwolves. John shared that he signed with a new team called the Minnesota Wolves and is excited for the season. So from that full conversation of 24,000 tokens, we generated 414 memories. Now let's start asking questions. So what's interesting about the LoCoMo benchmark is it covers things like single hop, temporal, multi-hop, open domain. Single hop is something kind of easy. Temporal is obviously time related. Multi-hop is it might be like multiple parts of the question, and open domain forces the LLM to infer based off of the context that you've given it to answer a question that's not actually contained in the text. So let's go with single hop. So which team did John sign with on the 21st of May, 2023? So now we're asking it the question. You can see here that there were initially 414 memories. So it's pulled out 10 relevant memories of the 414. It's generated some relevant session summaries as well. And now it's basically saying that, yes, the expected answer is Minnesota Timberwolves, and the judge is saying that the result is correct. The response correctly identifies the team as the Minnesota Timberwolves, matching the expected answer exactly in terms of team name. Although the article "the" is omitted, this does not change the meaning or accuracy of the answer. So essentially what this is telling us is by leveraging the memory context instead of the full context. So now we're using 1,335 tokens instead of 24,229 tokens. We were able to get to the right answer, and that's literally a 94.5% token saving. So essentially, without memory, you might be able to get the answer, but in this scenario, you would have to inject full context or over 24,000 tokens in the prompt, Whereas if you're using memory and getting, answering the query from our memory context, you're saving 94.5%. Why don't we ask another question? So this is open domain. This is a little bit harder. It's not sort of just a single hop. Would Tim enjoy reading books by C.S. Lewis or John Green? So when we click that, so now we're asking the question. All right, so now for this question, this open domain question, we've now pulled another set of 10 memories with session summaries. This time around, it's 1,467 tokens, still materially less than full context. What's interesting though is if we look at the memories here just very quickly, I don't see anything about C.S. Lewis. I don't see anything about John Green. So that's why it's more open domain. So let's read the answer. Tim enjoys fantasy and self-improvement books. C.S. Lewis is known for fantasy, example Narnia, while John Green, likely John Green, writes contemporary young adult fiction, less fantasy focused. Tim's favorites include Harry Potter, Game of Thrones, and Patrick Rothfuss, all fantasy. He also likes books on growth and psychology. Therefore, Tim would likely enjoy C.S. Lewis more than John Green. So you can see here some memories here, like Tim has his favorite books, including Harry Potter. But essentially, the system was able to intelligently handle an open domain question where the exact fact or answer was not contained within the memory context, but it still used the memory context to identify the correct answer. So again, here we got to the right answer with 1,467 tokens instead of, without memory, 24,229 tokens. So we're literally talking about a 93.9% savings under inference. So our goal is for you all to use memory, and then you'll hopefully have a lot more to invest in Cockroach and purchase their core product. Why don't we go back? I'm now going to show you the agent trace and execution demo. So this is different than a sort of long conversation context, right? This is not, sort of an agent, acting as like a customer support agent with a human end customer. This is, hey, agent, I'm going to give you a complex task. I want you to just go figure it out and come back to me. So let's even look at what this task is. Like, to be honest, it's hard for me to even understand what they're saying. For each genre, identify the single best-selling track by total units sold on invoice lines, joining track to genre. If two tracks tie on units sold, pick the one with higher total revenue, sum unit price by quantity, return genre name, track name, units sold, and line revenue. All right, let's start the demo and see what happens. On the left, we have with memory. On the right, we have without memory. So before taking a single action, memory services what it already knows from past sessions and injects it directly into the agent's context. So you can see the 5 retrieved memories here. Because the schema structure and query patterns were already known, the agent skips straight to writing SQL. Without memory, the agent on the right is still figuring out where to start. So now we're going to let it run. The agent with memory finished the task first, while the agent without memory is still mid-execution. Because the agent with memory arrived with context already loaded, the agent knew exactly where to start. So we'll now let the agent without memory finish its task. All right, so essentially, if you compare the two, on the left side with memory, we were able to accomplish the task in 2 steps with 2 tool calls in a runtime of 10 seconds, and total tokens used were 26,000 tokens. If we look at it without memory, so it started from scratch, it didn't have all of that relevant context, it took 5 steps and 6 tool calls in almost 17 seconds and consumed over 51,000 tokens. So essentially in this scenario, there were 60% fewer steps, almost 50% fewer tokens, 41% faster with memory. And imagine if you have an agent or many agents, doing many, many tasks. What we're seeing in our sort of live deployments in production is this actually compounds over time. So the difference is the delta between with memory or without, will get larger as you go.
Yeah. And if I can just jump in, Adam, I mean, great demos, by the way. And I think what you kind of showed here is some of the challenges that we were introducing early on, right? There's a question that came out. The one question by Dishant here says, and feel free to answer it, is the open domain question reasoning would have been possible because of the reasoning LLMs, right? The memories benefit would be narrowing down to the memory chunks in the LLM, or is there something that they're missing?
Yeah, great question. So, LLMs know how to reason. When we talk about, if they're going to arrive at the right answer, how quickly will they arrive at the right answer and how efficiently, that's where memory comes in. So you are correct that if I injected full context into the prompt, the LLM would have been able to arrive at the right answer in that scenario. But the difference is it would have taken, 25,000 tokens or whatever the number was. If instead, we sort of vectorize the prompt before it hits the LLM, and put highly relevant memories, attach that to the query as context. Now the LLM, which is doing the same reasoning, can get to the answer, with call it 1,200 tokens instead of 25,000. So you are correct. The LLM is going to know, how, in that scenario, it will get to the right answer. The question just is, what's the most efficient way to get there? And obviously in that scenario, it's memory context. What I will say is, feel free to go to our Memory Lab site and look at some other demos. There are scenarios in there where the agents fail completely. They hallucinate and fail without memory. So that's critical, as well, right? First order is you need accuracy, no hallucinations. If you then have accuracy, it's then about efficiency, and we strive to achieve both.
Right. Another question that has come up is, can we say that CockroachDB is the backend database for agent memory and memory labs? And memory labs is the brain that decides what to store. Is my understanding correct? This is from Saurav.
Yeah, 100%. So we play really nicely with Cockroach as a sort of tier one, database substrate, and our system will decide what to create, what to retrieve, but it's all stored in sort of that resilient Cockroach database.
Yeah. Another question from Nicholas. We'll take this and then we'll keep going. Is, do you need to chunk the conversation transcripts before you put it into memory, or can memory just scan the transcript and separate it by intent?
Yeah, so you don't have to chunk, you don't have to do anything. One line of code, get in there, and memory will essentially understand what semantic triples to extract from those documents or from conversations. So yeah, there's no pre-chunking or anything like that required.
Yeah. And that was also like, this is a great question because when I started talking to memory and I started playing around with it, my question was the same thing because that's what I was used to doing. And what I really liked was they had really packaged everything in such a nice way that when you set up memory, it sets up the database, it sets up the schemas, and then when you start having the conversation, it automatically takes all of that information, translated into, and creates the data into the database. So all of this extra stuff that you're used to doing, you really don't have to do it with just the way memory and Cockroach kind of work together. So it's like a bundled product together. You can just get started with. So yeah. So Adam, why don't you continue, and we'll come back and address rest of the questions. Yeah.
For sure, yeah. And just for the enterprise, customers on the line, we care a lot about sort of compliance. So, SOC 2, HIPAA, GDPR, ISO 27001. Really important that memory runs as a private memory fabric with tenant isolation, fine-grained access, and full compliance. So yeah, I wanted to bring up some alternatives because you all might have heard of sort of Mem0 as an example. So a big sort of differentiation from our perspective is we're the only agent native memory system structuring memories from agent execution and conversation. No one else is doing that right now. We pride ourselves on being SQL native. And still achieving state-of-the-art performance without sort of turning this into an infrastructure science project. That's why we love working with Cockroach. So we think for the enterprise customers that we aim to serve, being SQL native, RDB native is critical. We want this to be seamless to integrate. We don't want you to rip and replace all of your infrastructure. We want to be able to handle all types of memory, not just your agents speaking with humans, but also actual agent execution. So bottom line, we meet developers where they are. No vendor lock-in, no new infrastructure, and no trade-off between accuracy and cost. Yeah, so I wanted to mention this as well. We pride ourselves on being available in sort of all the agent harnesses. We actually do have enterprises that have come to us and said, hey, I'm equipping every one of my employees with an OpenClaw agent, and I want memory to be sort of the internal cognitive layer. So that's a really, really exciting deployment when we get that opportunity. So we support, OpenClaw, Hermes agent, MCP. We want to make it easy as possible for you, depending on the harness that you use. So in terms of when to use it, it's crazy, right? It's kind of like me saying, when should I use memory as a human? The answer is all the time, but just wanted to highlight some specific scenarios that we're seeing from our customers. So obviously customer support, remembering customer history, tickets, preferences, sales and go-to-market, track every touch point, follow-ups feel smarter, deals close faster. We're doing a lot of work with various e-commerce platforms because they want they want the agent to remember user preferences. The sort of internal cognitive layer personal assistant workflow is something really exciting for us. Yeah, healthcare as well, education. It's a very broad ICP. And then, yeah, just basically to sum up sort of business impact. So we think the cutting inference spend is massive, right? I think right now AI is still very early. Everyone's focused on token maxing. We think that pendulum is very quickly turning in the other direction. The CFO is going to come and say, hey, you chew through the whole annual budget in a month. How are you going to fix that? We think memory is the solution. It's very, very critical that you're not just reprocessing the same context over and over again. And then, of course, sort of durable memory enables long-term personalization, continuity, and contextual awareness, which stateless LLMs will never be able to achieve. Wanted to mention some of our, open source traction, similar to Cockroach Labs. We have an, sort of open source ethos here. And it's been very exciting for us. We're at over 14,500 GitHub stars, hundreds of thousands of downloads. The most exciting thing for me is when, someone comes in with a personal email and then we enrich it and we find out, oh my gosh, they're a senior member of a technical staff at some massive enterprise. And then we can identify them as an SQL and sort of try and convert them top down. But yeah, our ethos and foundation is always open source and, really respect and support that community. And then, yeah, I think we've hit it really hard, but just in terms of our joint value, we fundamentally believe that memory and Cockroach together sort of form the backbone of stateful, personalized, cost-efficient, compliant AI agents in production. Ease of integration is critical. Cost optimization is extremely important. We are built for enterprises. My co-founder and CTO, Mike Montero, a previous company that he built was Resi, the restaurant reservation platform, which he sold to American Express. So we always say, how can we build a memory solution that American Express is going to want to use? So we really care about, sort of putting ourselves in a place that we're easy to use for enterprises. And then again, because we're SQL native, we're production ready. There's no friction, there's no new data paradigms, and there's no learning curve. And then, yeah, I want to mention just some of our partners really appreciate, the partnership with Cockroach and, Spencer's support. Here's a nice quote from him talking about memory being a great fit with Cockroach Database. I also pulled up SK Networks, which is a large conglomerate in Korea. They are building a line of wellness robots and want us to be the memory layer on, for their robots on the edge. All of this happens because we're RDB native and have sort of the backbone of, the top database provider.
Yeah.
Um,
Adam, I just got some information. Like you have Spencer's quote here, but actually we have Spencer live on this webinar today. I would like to invite him over, and there's a lot of excitement around what we're doing together. Hey, Spencer, how are you doing?
Doing great. Thanks, David. Good to see you, Adam.
yeah, real pleasure, Spencer.
Great. So, Spencer, I mean, I know we've been talking about this internally at the company, and now we're partnering with Memory Labs. What are you excited about with the way everything is coming together?
Well, it's first of all exciting how many people are tuning into this. This is definitely a popular webinar, and for good reason. I mean, agents are certainly on fire because they represent I think the single greatest sort of tangible outcome of this whole AI paradigm shift. Like, how do we get humans doing more leveraged work and get agents doing like way more than humans would ever want to do, underneath. And I love how memory works so well with Cockroach and, right out of the box. Our theory or thesis really on databases in AI has certainly evolved quite a bit recently. So how we think of Cockroach is it has a huge part to play in really bringing agents to the enterprise. And this is actually a very multi-layered set of capabilities that are necessary. Now, on one hand, yes, you need memory for these things, and it has to be stored somewhere. It's kind of like not just the memory that is being accreted over time in terms of the decisions that the agents are making and learning from mistakes and analyzing that, but also how do you bring like an enterprise's existing knowledge safely into the agent's awareness, because nobody in the enterprise is going to do what a lot of kind of YOLO type uses of agents across the industry are currently doing, where you kind of give them credentials and the access systems of record and things. It's kind of a preposterous suggestion in a regulated enterprise, but you do have an ability to say, okay, we're going to curate data and we're going to make that available to the agents. But when you start thinking about what agents need, there's a number of different things that have to be true. One, they're going to need their own metadata, not just the memory and so forth, but like, exactly what was done. And this is something where you're going to want to have lots of cockroach clusters, right? You may want one per agent. And that is a fundamental capability that we have with Cockroach, which is the idea of virtual clusters. So you can have tens or hundreds of thousands of virtual clusters in one Cockroach cluster. So you don't have to worry about all of the difficult issues if you were going to try to pack those into fairly potentially noisy neighbored Postgres instances or something like that. Cockroach has solved this problem for about 6 years now with our serverless capability, and that's actually something that Memory works with out of the box. And it's also something this year that we're bringing to self-hosted and to more of an enterprise flavor, not just something that you use in Cockroach Cloud, but something you can self-host, depending on if you have a private cloud or you run hybrid or you're running everything yourself. Many enterprises choose to do that in the public cloud. But there's another interesting part of agents, right? It's like these agents represent an ability to have vastly more traffic, right? A lot of activity. They can be very exhaustive in terms of their interactions. And ultimately, when an agent calls any API, that actually is going to hit an operational database in the back end. So
Right.
it's one thing to think about all the databases that you're going to potentially want for your agents. And you might have multiple agents per customer. Like a big bank might have 10 million customers and they might have 50 million agents. That's
Yeah.
crazy, right? Those agents are doing things. That ultimately translates to traffic. And so all of those other APIs and all of your kind of sleepy legacy application database estate, those databases are going to get really busy. Right.
Right.
So it's like, is it going to be 10 times more traffic? Yeah. Is it going to be 100 times? Yes, it will be. So how do your single Oracle instances or your Postgres instances, where you might have maybe a 2x, 3x headroom, where you think you can scale that much if you put it onto a bigger box and that sort of thing, that's a dead architectural pattern. And the reality of that is going to become crushingly obvious to people in the next couple of years, because agent traffic right now is on an exponential and it's still small compared to the aggregate of human traffic. But man, that thing, when it passes human traffic, it is going to be going vertical. So
Yeah.
that's going to create enormous pressure on data architectures. And you have to be on distributed infrastructure. That's all there is to it. You cannot build these things on Postgres anymore. And that was kind of a reasonable pattern in the past. And maybe 90+% of all apps out there are running on monolithic, non-distributed infrastructure. So that's another very interesting thing. And finally, I'll just point this out, and I think this is really where memory shines as well. It's like, what is the coordination, the choreography between all these agents? Ultimately, they have to share some state. They have to, for example, take things off work queues. You might want to take like mutually exclusive like locks so that an agent can sort of uninterrupted or with no concurrency do things safely on its own, whereas other agents might be trying to compete for that. What do you need in the middle of that? You need like something that supports these distributed systems primitives. And actually, like this is a very old pattern for Cockroach. We have a number of customers that are ultimately building distributed systems themselves. There's a company called Materialize that does a really cool sort of timely data flow analytics product. And they chose not to solve the really difficult distributed systems problems because Cockroach already solves them. So you can put your state into Cockroach, but you can also use Cockroach to get a single source of truth, even globally. And when you have that to build on, you can pretty much build any distributed system. And the reality is that every single company in the world that isn't going to be extinct in a couple of years is going to have a distributed systems problem, which is all of these agents. How do they run? How do they interact? How do they do it safely? Like you fundamentally need something like Cockroach. You need something like Memory. These things go hand in glove. It is actually like the future is inference, agents and databases fundamentally. So we're very happy to support this partnership, and congratulations, Adam, on the fast progress.
Yeah.
Thank you.
Awesome. Spencer, thank you so much. Those are really great. I'm sure everyone listening enjoyed your wisdom and your thoughts around all of this. Adam, why don't you tell us a little bit about where you're going, what we are going to be doing next?
Yeah, for sure. So it's very critical for us. We think that there's going to be an explosion of different harnesses. So just putting us in a place that we can support all of that. We really want to make sure that we're tailoring memory to the enterprise customers that we want to serve as well. We talk about, extracting memory, not just from agent trace or conversation, from documents, memory seeding, really being sort of that cognitive layer for the enterprise. And again, we still think all this is very early. Hearing Spencer talk about, enterprises not even being on like a distributed databases. I mean, imagine then what's going on with, actually allowing, agentic workflows to proliferate in production at the enterprise. So we're just really excited to continue, speaking to customers and really engaging in customer-driven development. But we think we're in the right place at the right time, and it's always really great to partner with incredible folks like Cockroach Labs.
Right. Yeah. And what Spencer said, like, this is something that we have been actively thinking about as a company, right? And I think one of the biggest mistakes I've seen a lot of folks do as we start conversations with them is they're trying to build these platforms on their own. And then they're creating these problems. What you mentioned, what Spencer mentioned is like just token maxing, right? Like you have to start thinking about how to build systems that can scale and also add, operational benefit to you. So I'm really excited about our partnership with you guys, especially this bundled product that is there together right now. Why don't you take it off by giving people the next steps and how they can get started?
Yeah, for sure. So, typically what we like to do is sort of align on use case architecture and success criteria. And assuming, we can deploy, according to your deployment method, it's very, very easy to quickly see the impact, literally just track tokens saved, latency, personalization. And we usually do like a quick sort of 2-week pilot on that. And then if everyone feels good, we then work on, sort of production rollout. But again, as I mentioned, it really all starts with sort of our starter and pro users that find us through the open source community. So we put a little QR code here for anybody that wants to. You can scan the QR code and get 3 months free of Memory Pro access. That essentially gives you 150,000 memories created per month through our advanced augmentation engine. It exposes our sort of intelligent recall and decay curves. If you access us through Memory Cloud, you can then get sort of all this dashboarding to actually understand what's going on. But yeah, our hope is, use the product, give us your thoughts, the good, the bad, the ugly. And, we've got a lot of enterprises really excited as well. And I know there's a lot of enterprise user and buyer personas on the line. So we'd love to get on the phone, talk about how this can work for you and take the next step.
Awesome. Well, thank you, Adam. This is great, by the way. And now you have to get ready for the rapid fire because we have about 14 questions in here that we got to address. But we will respond to all of you. You have all your information from your sign up, so we'll connect with you. Please feel free to reach out to us. But we'll keep the responses short, just in the interest of the amount of questions we have with the amount of people today on this webinar. So I think the first question is. By Nicholas, do you need to chunk the conversation transcript before you put it into memory, or can memory just scan the transcript and separate it by intent?
Yeah, so you do not need to chunk. It can sort of work out of the box. The most important thing is just that you assign what's called attribution. Memory will separate memories, by tenant, user, project, session identifiers, etc. So, literally, put in your LM client, your Cockroach database. Handle attribution, and then it'll work literally right out the box.
Got it. And the next question is from Mario. And this is a little long, so I'm going to paraphrase it. It seems like choosing the benefit of token cost savings is dependent on choosing the correct memory, right? So the question is, what happens if the information is not stored correctly in memory? And what if there's a false positive and then you have to go read the whole memory and the full context? Like, how do you help protect that?
Yeah, so it's, a lot of what, sort of our proprietary solution is ensuring that number one, we're structuring the memories in the right way at the advanced augmentation or memory creation process. But then number two, whether it's sort of automated injection of memories, on the human side or sort of the agent actually manually retrieving memories, that we understand, we very sort of quickly shrink the corpus of memories that are, that sort of, relate to the query, and that we identify the right memories at the right time. So, obviously things could in theory not work, but overall for us, just given our LoCoMo benchmarks and the accuracy that we're seeing, we've done a really, really good job of ensuring that the agent is equipped with the right context at the right time to get to the accurate response in the most cost-efficient manner. But there's a lot that we're doing under the hood when we think about intelligent recall. a combination of things like cosine similarity, BM25, all of the sort of ranking that we're doing. There's multiple variables in terms of how different memories are on different decay curves. The goal is to really put your agent or agent in a place that it's getting the right memory at the right time. So we pride ourselves on sort of our accuracy rate and just ensuring that memories are created, in the right way, and then obviously that the right memory is recalled, so that you don't have to, sort of look at, full context, which is extremely inefficient.
Got it. Yeah. And there's another question that Dishant asked. Does memory need some kind of bootstrapping to understand what agent is doing, or as it gets started? My experience when I started trying around the product was there's no bootstrapping. It just starts and we just have to start pushing the data through.
Totally, yeah. So the concept of saying, "Hey, I want memory to start structuring. I want my agent to start structuring memory primitives from all of its activities, all of the conversations." You don't need any bootstrapping. It's literally going to work right out of the box. So the memory is going to know what are relevant semantic triples that need to be saved. What's durable agent, sort of trace that needs to be saved. What's exhaust that shouldn't be saved, and it'll just start working. What you might be saying is, "Hey, what if there's like additional context that I want my agent aware of?" Beyond just what it's actually doing in real time, we would call that like memory seeding. And that's a scenario where, in theory, we can create memories from existing documents, to put you in a place that there is some sort of, knowledge base to start from. But at the end of the day, the concept of just saying, "Hey, I want my agent to remember what it's doing, remember the customers that it's speaking to, understand where it's being successful, where there are failures, and to improve over time," all of that works right out the box.
Got it. Yeah. And this question kind of came a few times, so I'm going to address it. So, what is the latency overhead for memory retrieval versus just a standard LLM call? Obviously, we know there is latency, but these are different aspects. Do you want to respond to that? And a part to that question also is, how does memory handle memory conflicts when multiple agents are writing simultaneously?
Yeah, great questions. Yeah, so we pride ourselves on sort of being enterprise grade and ensuring that this actually works for agentic workloads in production. So if there was too much latency, that would be a problem. We are literally seeing like 250 milliseconds of latency. So where latency actually matters is actually in the conversation context, right? When an agent is speaking with a human. In that scenario, like the answers need to come very quickly. And yeah, we're doing all of the advanced augmentation asynchronously in the background. So we're only seeing 250 milliseconds of latency. So nothing that a human would even notice. What is very interesting is actually on the agent side, when the agent's on its own and just, sort of solving a complex task on its own without a human or anything else, latency doesn't really matter. Obviously, we don't want like crazy amounts of latency, but the concept of like, "Hey, we added a second of latency," it really wouldn't matter because it's just the agent doing something on its own. What matters in that scenario is accuracy and cost savings. But yeah, so we pride ourselves on not creating too much latency. We care a lot about that in the long conversation context when there's a human on the other side. And yeah, it's been designed in such a way that we're literally only seeing around 250 milliseconds of latency. There was
Right.
another question, David.
Yeah. Yeah. The other question was basically around how do you manage memory conflicts when multiple agents are writing or reading?
Yeah. So that again, right? It's really important that attribution is sort of critical, right? I loved even when Spencer said like each agent should get its own database. We think it's really important that memories are separated by tenant, user, project, and session identifiers. So every memory that the agent is creating for itself, sort of just for that agent. Now there are scenarios, right, where all of a sudden the agent loves green apples, and then the agent hates green apples, and we essentially, based off of our intelligent recall system that we've created, we have the ability to deal with duplicative memories, disambiguations, and that's all something that sort of happens on the back end. So we will literally be in a place just given how complex all the variables are that decide should a memory be recalled or not. When you look at something like frequency, just as a very rudimentary example, if I said I hated green apples, now I love green apples. Well, I love green apples is, more frequent and more recent than I hate green apples. So in theory, that would be prioritized. But it's very, very complex under the hood. In a scenario where multiple agents are writing to the same memory pool, we would basically treat it in the same way. So we would be using things like deduplication, disambiguation, and sort of the different decay curves to ensure that the right memory is retrieved at the right time.
Right. Yeah. There's another question. I mean, it's an interesting one, and let's see how that goes. So, for memory lapse, was there particular reason why you went choosing a relational database versus a NoSQL database?
Yeah, great question. So, we do as an open source player, sort of support other databases. But from our perspective, in terms of an enterprise implementation, it was really, really critical that we fit and work with the infrastructure that our enterprise buyer personas already have and already use. So we talk a lot about sort of like head of AI going to the CFO and saying, hey, I know we're spending a lot on tokens. I can save us millions of dollars, but I have to rip and replace all of my infrastructure. We just don't think that's plausible for the average, enterprise organization. So it was very, very critical. I think it speaks to just the maturity of our team, and we made it harder on ourselves, right? We wanted to get sort of top tier benchmarks, but using sort of infrastructure that is already available. Now, obviously, with Cockroach, we can take everything to the next level, but we want to work with sort of all RDBs because that's where we believe the enterprises are.
Yeah. And I just have a thought. I mean, this is just my thought. And I think I'm going to echo a little bit of what Spencer had shared earlier is that the world we are going to see and what we anticipate is the scale at which agents are going to work. Say you're a banking customer, when Spencer gave this example, say 10 million customers, you will have, say, 15, 20, 30 million agents working in a multi-agent system. Now, how do you build an infrastructure that can scale and be resilient, right? And most companies like Memory and other partners we work with, they also support other databases. But the world that we anticipate is the world that needs scale and resilience for the same agents as much as we need it for humans. And so that's where Cockroach kind of fits in the story, right? And that's where our partnership kind of will help if you're building for that kind of a world. So it's great. I mean, we still have a lot of questions. Adam, we can't address everything, but for everyone whose questions we couldn't address, we have all your information. We'll make sure that we connect with you and we'll pass on the information that you asked. I would leave with one last question, Adam, for you. For anyone getting wanting to get started with you, how can they connect with your team? Do you have the best way to connect with your team is like reach out to you or LinkedIn or give
Yeah,
us a little bit of that. Yeah.
Yeah, so we pride ourselves on being like super responsive. You can literally go to memorylabs.ai. So it's memory with an I, memorylabs.ai, and book a call. And it's very plausible that I will join that call and we'll chat. So that's a very easy way. You can also find us on GitHub. You can find us on Discord. You can find us on X. We've got a great, DevRel team as well that's super excited to speak with you and answer your questions. If you get a pro plan, you can actually get us in a Slack instance. So we would love the questions. Hit us up. The more activity, the more momentum, the better.
Awesome. And for everyone listening in, if you want to connect with Cockroach Labs team, or you go to our website, you can connect with our team over there. A question that was asked was, hey, what if I want to get started with memory? Obviously, as an action, scan this. It's going to take you to all the information that you need to get started. If you want to run Cockroach, we recently released a Claude plugin and a Cursor plugin. And a question that Dishant asked was, hey, if I want to run it on client machine, how can I get started? I would say go play around with these plugins. They will set up CockroachDB for you. And if you can access the memory as well, you can connect both these systems and start playing around with it. And we're going to come back with more such webinars. And you will see Adam more often, and will basically go in and maybe do a little bit more enablement on going into the system a little bit so that you can see on how to get started a little bit more next time. But hopefully, this was a great introduction to what Memory Labs does and how you can build long-term persistent memory. So, Adam, thank you so much for your collaboration on this. This is fantastic. And thank you everyone for dialing in again. Appreciate it.
Thanks for having me.